Sorry for that interruption. My iPad went crazy. So we left off at this point in time where our future value is 35.22 and a bunch of change. So we're right here on the timeline. Now we need to move forward and find future value 2. All right, so when we find future value 2, this future value 1 actually becomes the present value of our future value 2. And we are moving that forward with a constant interest rate of 0.012, and it's being compounded semi-annually, and our new time frame is 1 year and 3 months. And when we get to our future value 2 and we're stopping, we're adding in that deposit of $1,600. All right, so let's find future value 2 plus the $1,600. I'll just punch that into my handy dandy pocket calculator. And I get $3,575.58, and then I'm going to add the $1,600 to it for a final amount of $5175.587838. All right, so now we are here on the timeline, and we just need to move that money forward one more time for future value 3. And again, this old future value becomes my new present value. I transfer it with all of the decimal places intact, and it's going forward at 1.2%, compounded semi-annually, and this time it's for 1 year and 11 months. And we can get our final answer, and this answer we are going to round to 2 decimal places. For a final answer of $5,295.64. All right, had we used the exact amount of days that were in between these, our answers would be slightly different. But because in compound interest, for the purposes of our class and future accounting classes, often we're just going to count by these months, and this isn't as exact as counting the number of days between. However, it is good enough for our purposes. All right, let's try another example where we have to stop on the timeline. Let's look at example 7, which is the last example I'm going to do with you in this particular section of the video. And it says, a demand loan is a rare form of a loan where a lender can demand repayment at any time with interest. Tatiana acquires a demand loan of $25,000 and plans to make repayments of $15,000 in 6 months, $6,000 in 2.5 years, and a final payment in 4.25 years. Interest on the loan is 11.25% compounded quarterly for the first 6 months, 8.5% compounded semi-annually for the 2 years following, and 7.75% compounded annually for anything after. Determine the final payment. All right, this question's overwhelming, all of the language that's in there and numbers. So it's often a best strategy to get a picture of what's going on in the question, with a timeline to help us to process what it is we need to do. So Tatiana has this loan of $25,000. And she plans to make some payments. She plans to make a payment in 6 months, so 6 over 12. She plans to make a payment of $15,000. So we're going to need to make a stop there and take off her $15,000 payment. And then in 2.5 years from time 0, she plans to make another payment of $6,000. And then at the end, in 4.25 years, she plans on making her last payment, but we don't know what that last payment is. We don't know how much she's going to owe after she has made those first 2 payments and interest has been added onto the loan. So this is very similar to the last example that we did. Our plan will be to move this $25,000 forward in time and calculate how much it is with interest and stop and take off the $15,000. Once we've done that, we're going to move that forward in time again and find a future value too, and stop and take off her $6,000 payment. And then we're going to add the final amount of interest on the loan and calculate our future value 3. In that, my fine folks, is what she will owe as a final payment. All right, so we know that to do a compound interest calculation, that we need all of the pieces from our formula. And we see here that the interest rate and the how it's being compounded is changing. Now, I find it beneficial if I write what's happening on the section of the timeline that I'm dealing with. So clearly the time here is 6 months because I'm going from 0 to 6 months, or I'm going half a year. And in that first half of a year, interest is 11.25% compounded quarterly. So my I is equal to 0.1125, and we are compounding quarterly. Now the second part of our timeline, we also need those 3 pieces. We need the T and the I and the M. So sometimes calculating time is difficult. However, here we can see that it's just 2 years because we're going from half a year to 2.5 years. But if ever you're in a pickle, you have something more difficult, you just, to find time, you just go, where am I ending minus where am I starting? And that will give you the time between, and in this case it's 2. And that second part of the interval, we have an interest rate of 0.085 or 8.5%, and it's compounded semi-annually. And then lastly, on our interval, we have a time frame that's going from 4.25 minus 2.5, or 1.75. And our final interest rate is 7.75%, and it's compounded annually. All right. So now we're ready to find all of our future values. We can start off with future value 1. So future value 1 is just the $25,000 loan amount that has an interest rate of 11.25% compounded quarterly for 6 months. And we know that once we find that future value one, that we need to stop and take off that $15,000 payment. All right, so we can find what future value one is. And then we can subtract off the $15,000 payment for $11,426 and a bunch of change. All right, and so now we're going to find future value 2. And we know that we're going to transfer this amount down as our present value into our compound interest formula. This time, our interest rate is 8.5%, and it's going for 2 years. And when we stop there at future value 2, we have another payment of $6,000. All right, so we can get this into our formula, into our calculator, pardon me. And take off the $6,000 payment for a value of $7,495 and a bunch of cents. All right, so now here I am on the timeline, and I need to move that forward just one more time for a future value 3. And again, I'm transferring all of my decimals. I'm not leaving any out. Our interest rate is now 7.75% compounded annually, and it's going for 1.75 years. Which leaves us with a final payment of $8,541.81. All right, so those are the multi-step type of problems that you are going to see in this course. I'm going to omit this Miranda's banking statement, and also I'm going to not do this particular example with you for the purposes of our shortened videos, but you should be ready to do all of the student practice that is at the end of this lesson. Now, you will see that anytime you have a question in the student practice that is not counting from the 12th to the 12th, like this particular example here, it's going from the 12th to the 24th. I've actually given you how many days are between those two values. So for those questions, you can just use that time is equal to 2628 over 365. The only time you're expected to count time is when you are going actually from the 12th to the 12th, and you're going to estimate the number of months between. So anytime that occurs in the student practice, please feel free to use the days that are provided to you there. Similarly, you are welcome to not do Joshua's monthly banking statement. However, all other questions you can accomplish at this point. I will see you back in a few minutes with a new video on present value.